Hello everyone, welcome to today's video. So today we are going to simulate one interview scenario. Let's say you are facing one system design interview and the interviewer asks you to design one application, okay? And let's name that application as over for dog walkers, okay? And we expect maybe 500 users in first month, and also we have to go live in next 2 months. So how do you architect this? Okay. So as part of this, we have to make a decision that which kind of architectural pattern that we are going to use to design this application. Okay. Although we will not go in much details from implementation perspective, but we will try to think in a way that which kind of pattern should be applicable. Okay. So let's think for 2 minutes. Okay, let's come back to this particular question. So what could be the required functionality in this particular scenario, right? We are, as we are designing over for dog walkers, right? So there will be the pet owners who can create their profile. They can add dogs, right? So here we might need a pet profile service, right? Or user service. The second functionality could be dog walker sign up verify, right? So dog walkers can again use this user service, and for sign up and verification, we might need authentication and authorization service, right? Where a user can log in, log out, token verification, all these things will be taken care by the authentication and authorization service. Okay. We need to have a dog owner, right? And once the dog owner open the application, they will see nearby walkers and they can request a walk, right? So it might be a booking service that we might need here, right? Okay. Then after booking a service, so there will be a matching service which will be responsible for matching the owner with a walker, right? So in that case, there might be two kind of scenarios, right? Either he needs immediate service or they can schedule that service in advance, right? So we will be needing a matching service here. Okay. So the next scenario could be like walker picks up the dog, okay, walks the dog and returns it. Okay. So for this, we might need a location service, right? So that owner could see where that walker has taken the dog, right? For this, we will definitely need a payment service, and the payment will be taken care in application itself, and we will be needing a notification service as well. So to notify both the owner and the walker, right? So these are the different kind of services we will require for this particular implementation, right? So all of these services I have listed down here, and we have already gone through them. And one more service that we need is rating and review service, right? And the admin service as well. Okay. So now the question comes that we do have 2 months of timeline. In 2 months we have to go live. Okay. And we have these 11 services. Okay. So which is the correct approach or which is the correct design pattern uh, using which we will be able to achieve this? And uh, so there is a concept of product market fit, right? So basically product market fit is nothing but uh, a startup sees a situation, they will try to come up with a product in the dedicated timeline, okay, and they will try to introduce their product to the customers. So that is product market fit, right? And now in this particular situation, if we are going to use microservices, then definitely there will be n number of services, and we have to set up the communication among them, right? So before we take a decision that which approach we should take, let's first try to understand what all kind of architectural patterns we have, okay, and what are the benefits and drawbacks of each of them. And then based on that, we will try to understand that for this kind of situation, what could be the possible answer. Okay. Okay, we do have the monolith, right, as the first architectural pattern. So here you can see I had described the monolith as a single ball of mud, right? So here in a monolithic application, all the features, modules, and the business logic is actually built and deployed as a single application, right? Everything will be tightly coupled here. We do have the features, modules, all the business logic, even the database. Okay. So every module will be calling each other, and those will be tightly coupled. Here, yes, we do have a single repository. We will be having single CI/CD pipeline. That is the benefit, right? The biggest benefit is debugging is easy in this case because you can directly use F12 or go to definition to actually see the complete request flow from API to the database, right? You can see what all functions are being called, right? And when I'm saying a function is being called, right? So it is a in-memory call. So it's like very fast, right? There is no network hop or network latency available, right? Uh, the only problem with this monolithic approach is that it is designed only for vertical scaling. So what is vertical scaling? Let's say today you are getting only 100 users, and maybe during Black Friday sale, you got some 10,000 users onboarded to your application, right? So that subsequently the demand of your application got increased. So in such cases, we cannot horizontally scale this particular application, right? I cannot have multiple instances who can actually take care of user requests, right? The only option is vertical scaling. So we can actually increase the CPU, we can increase the memory, right? But so basically what we are trying to do here is we are trying to improve the hardware of our system. And definitely it has a constraint, and the constraint is cost, right? So the cost will exponentially increase after a certain limit. Okay. And another problem with this kind of architecture is uh, single point of failure. So here, uh, everything, all of the components are acting as a single point of failure. So for example, in booking service, if user is not able to book the dog walker, then what will happen? The complete application will go down, right? Because everything is tightly coupled. If one component fails, the complete architecture collapses. Okay, so this is the problem with monolithic applications. I remember in my initial days of my career, I used to work on monolithic applications. So I had seen all the pros and cons of monolithic applications. Okay. Now, the next approach or the next option available for the architectural pattern is service-oriented architecture. Okay, so this I have already described in more detail in one of my Substack blog. Okay, so there you can go and check it out. But let me summarize it here. So in a service-oriented architecture, uh, we have segregated our monolithic application into different services. So here you can see service A, service B, but these services will still communicate with a single database. Okay. Uh, Here we do have the concept of service boundary, right? We do have segregated the services. So we have service boundaries. And if these services want to communicate with each other, then they will use SOAP, WSDL, or enterprise bus service. Okay. So remember one thing here, the services are very heavyweight services. Okay, these are not lightweight. So this is another approach that we can take. Okay, but the third approach is microservices. This is third option in our service-oriented service architecture. So in microservices, we do have a web application, okay, and then we do have a couple of services. So for example, here you can see service A, service B. And these services are very lightweight services because these are focused on a single business capability. So for booking, we will use booking service, right? For user profile, we will be using the user profile services. So every service have its own business functionality. Okay. If these services want to communicate with each other, then we will use light protocols like REST, gRPC, or async messaging. We might use Kafka, right? SQS. Okay. And definitely we do have database per service. So this is the benefit that microservices provides us. So for service A, I can use MySQL as database. For service B, I can use PostgreSQL as database. Okay. Or maybe DynamoDB. We do have polyglot persistence. So it means one service can be written in a different technology like Python, and the other service can be written in, let's say, .NET. Okay, so based on the behavior, we can actually take the decision and we can choose the technology. Okay, we will be having independent CI/CD pipelines, and the biggest benefit that microservices provides is horizontal scaling. So let's say 2 months down the line, if my user profile service is actually is facing 100x traffic, then I can actually horizontally scale the user service alone, keeping all other services running on the minimal instances. Okay, so that is the biggest benefit of microservices. Okay, uh, so now we have seen all of the options that we have to design this particular problem. Now, what will be your answer in this particular scenario? Will you go for microservices and design these 11 services individually? And will you go for monolithic, or will you try your luck with the service-oriented architecture? Okay, so I think most of you will be relying to create this architecture as microservices, right? So let's see what are the drawbacks microservices have. Okay. Okay, we will see microservices drawbacks. And if you are trying to pick microservices architecture and trying to implement these 11 services in just 2 months line, I think you are wrong. Okay, so we will see what are the drawbacks. First drawback is latency. So in a monolithic application, we had seen different modules can actually call each other. For example, we have order service, we have inventory service, and we have database. If my order service needs to call inventory service, then it will be a simple function call, and it is actually a in-memory call, right? So there is no network hop uh, here, right? So there will be very less latency in this particular case. But in case of microservices, the biggest challenge is network latency, right? So if order service again wants to communicate with inventory service, then uh, maybe order service is actually running on a separate machine, node 1, and the other service is running on separate machine, which is node 2. So if I need to call inventory service from the order service, then I have to make one HTTP call, right? So there will be network latency, retry, all these things will be available, right? We have to include all these into our consideration. So subsequently, the latency will increase here. Okay. Uh, Another major drawback of microservices is consistency. Okay. So in case of monolith, if you see, let's say when user tries to initiate the booking service, and we have to use the matching profile, matching service, and subsequently we have to complete the payment. Okay. So I want all of these in a asset transaction, as an asset transaction. So my intention is if payment has been already done by a particular user, then we have to assign a particular dog walker to the owner, right? If payment is not succeeded, then we should not assign a dog walker to the owner, right? So basically, this is kind of asset property that we are looking into, right? So here, what I can do is I can begin the transaction, right? I can insert, update, match, whatever I can do, and I can commit the transaction. So the benefit of this particular approach is either all of them will succeed or none of them will succeed, right? So this is what I'm looking into. But do you think we can achieve this easily in microservices? Is it possible? Can we use simple asset transactions how we used to use in monolithic? Can we use it in the similar way in microservices? No, right? Because the main problem in microservices is we do have multiple machines or multiple nodes, right? We do have network hop, maybe multiple databases, right? So because of this, it is a distributed system, right? So we can actually we cannot use asset transactions and lock and wait for other services. I'm sorry. Okay. So can we use two-phase commit here? Uh, Maybe some of you will answer that we should go and use two-phase commit. But I will strongly deny this. We should never use two-phase commit in distributed architecture. Okay. Well, maybe some other time we will come and see what is a two-phase commit. But for this video, we are just trying to check the available options. Okay. The best option for this kind of scenario is to use Saga pattern, right? But definitely Saga adds complexity. Okay. So this is another major drawback of microservices. And the third major drawback is DevOps problems, right? In a monolithic architecture, you can actually go and maybe two or three developers can take care of building the service, deploying, and resolving the production bugs, right? But in case of microservices architecture, now we have 11 services. Three developers cannot take care of this, right? And we might need to set up a separate DevOps team, right? Who can actually work on Kubernetes, who can work on service discovery, right? Because my user profile service needs to know where my booking service is available, right? We might need service mesh, we might need distributed logging, distributed tracing, right? So because now the complexity has been increased, so we need to set up a separate DevOps team here. Okay. So these are the drawbacks of microservices architecture. Okay. So if we come back to our original interview question, so do you think that we should go with microservices architecture now? No, right? So let's create a checklist. So in which all cases we should not rely on microservices architecture, or we should not pick this option. Okay. So when not microservices. Okay. So let's say if your team size is less than 50 people or 50 developers, do not go for microservices. I think we have already seen now we have 11 services, and if you have 10 developers, all of them cannot take care of all these services, right? Second is if you are actually facing the scalability problem. So let's say your user service is actually facing 100x traffic more than your order service. Then you might go for microservices. But here I will recommend that you should first try fine tuning the database. Okay. And because most of the scalability related challenges can be actually resolved by tuning the database itself. And for example, you can add one index, right? You can fine tune your scripts there. So if you are able to increase the performance by just fine-tuning the database, go for it. Otherwise, you can pick up the microservice architecture. Okay. Third problem is, or if you actually need different kind of technologies for different kind of services, right? Uh, Tech per service, I would say. Then you can go for microservices. For example, you want to write maybe order service or booking service using Python and user service maybe using the .NET. Then you can pick the microservice architecture. Okay. And fourth option is FOMO. Do not go for microservice architecture if you are taking decision based on FOMO. What is FOMO? FOMO is fear of missing out. Uh, if you think because it is a best practice to use microservice in modern application, because Netflix is using it, because Google is using it, I should also go and use microservice. No, because maybe whatever problems Netflix is facing today, and you might not be facing those challenges, right? And whatever solution Netflix is coming up to resolve those challenges, maybe you do not need those kind of solutions at all, right? So never go or never pick a technology based on FOMO. Okay. So if not microservice, then what? Let me add one more page here. Okay. If not microservices, then what? What is the solution for this? Should we go for monolith and we should we go and create tight coupling between our all the modules and create a big ball of mud? No. Should we use service-oriented architecture and use those older technologies like SOAP, WSDL, right? Event service bus, I would say no. So what is the option? Do we have a middle ground here? Yeah, we do have a middle ground. So the solution is go for modular monolith. Okay, but there is a parallel option which is distributed monolith. I would say never go for distributed monolith. We already know what is a monolith, right? Now we have to understand what is a modular monolith and what is a distributed monolith. Okay, let's try to understand this. So here I have added one diagram. So here you can see that to create a distributed monolith, or let's say you are trying to segregate the services. Okay, so you don't want to create the monolith. So you are trying to segregate your services. For example, now you have user service, you have segregated order service, and let's say you have segregated payment service. So you have three services available here. Okay, but you forgot to remove the tight coupling. Okay, so maybe one of these service is actually uh, using the shared API contracts. Okay, and these are still using the shared database. Or let's say user service is actually calling your order service, and order service is calling the payment service, and payment service again calling the user service. So you have created a cyclic dependency. This is the cycle of death. Okay. So in such cases, all of these services have very tight coupling. So if you want to deploy user service alone, you cannot do, right? Because order service depends upon user service schema. Or let's say we have user database in our shared database, and order service can also make and update user database, and user service can also go and update user database. Okay. So basically here what we have created, this is not a monolith, this is not a modular monolith, this is not a microservice, this is a distributed monolith, right? We have introduced very tight coupling here. Okay. We have introduced network latency because we have segregated the services So if my user service want to call order service, we have to make the HTTP call, right? We cannot deploy them independently because there is a tight coupling we have, right? No service isolation is there. So this is worst of both the worlds. So do not go for distributed monolith. Okay. So what is the answer for this question? Modular monolith. Okay. So first we will try to understand what is a modular monolith, and then we will see what benefits it provides. Okay. So what is a modular monolith? So again, here also we will be having a single deployable unit. For example, one jar file or one binary file or one container, because all of my business functionality or all of my modules will be in a single application. Okay. But here we will be having all of my code structured into proper domains. Okay. We will not create a tight coupling between different domains. So for example, here we have billing context, we have order context, we have shipping context. So all of these modules we have, but none of these modules are tightly coupled. Okay. Here also we will be having a shared database that you can see here. Okay. So we will create some kind of golden rules for this kind of architecture. Okay. So the first rule is we should none of our module should actually go and import code from another module. Okay. So user module cannot import internal code or business logic of order module. Okay. This is rule number one. So we are actually trying to remove the tight coupling here. Okay. Second option is, second rule is the communication between user module and order module. So the communication between all of the modules should actually happen through API contracts. Okay. They can make function calls, but based on a predefined API contract. Okay. The third golden rule is, as we have already seen, here we might be having user database, right? So none of the other modules should go and update this particular database. So basically, all of these modules should take care of their own database modules or database schemas. Okay. So these are the three golden rules of creating a modular monolith. Okay. So here in this example, you can see we do have one API layer which actually defines the API contracts. Okay. We do have separate modules: user module, order module, payment module, inventory module. If I want to call order module from user module, I can make the direct function call. Okay. But code will not be imported. Okay. And this is the complete architecture of modular monolith. If we comes, what are the benefits this particular kind of architecture provides? So each of the module will have, or the code of each of the module will be in its own folder structure, right? We will be having clear API interfaces. We will have separate unit tests. And let's say in future, if my user module is actually attracting 100x traffic, then I can segregate this module. I can pick all of the code for of that this particular module, create it as a separate service, and provide an API which other modules can make us HTTP call to interact with the user module, and I can easily segregate it as a separate service and deploy it, right? So this is the biggest benefit this particular kind of architecture provides. Okay. So you can go segregate your one of the module as a separate service and continue serving the customers. Okay. So these are the three, all available options that we have to design the architecture of our problem, right? So let's coming back to this particular question. So here now we have already said that timeline is predefined, right? We have to deploy this application in 2 months, right? And what is the traffic? Traffic is only 500 customers, right? So considering all these facts, should we go for microservices? No, right? Should we go for modular monolith? Yes, we should go for the modular monolith. Okay. So this was a scenario-based question, and all of these details I have explained in one of my upcoming Substack article. I will attach the link. Okay. Thank you.